Hello everyone, my name is Prerna Bajracharya and I am here to present on my project named Malicious URL Detection using Machine Learning. Now let's move on to the introduction. With the increase in the use of internet, it has made us more susceptible to cyber attacks, including those that utilize malicious URLs. Malicious URLs are links that lead to websites that are designed to cause harm, such as malware infection, data theft, or financial loss. Cybercriminals use various tactics to trick users into clicking on these URLs. Once a user clicks on a malicious URL, their device may be infected with malware and their sensitive information may be compromised. Cybersecurity professionals use various tactics to trick users into clicking on these URLs, such as phishing emails, social engineering, or malware teasing. Use of machine learning and threat intelligence can be done to identify and block malicious URLs and prevent cyber attacks. This project deals with the detection of such malicious URLs using machine learning techniques. So, the objective of the project is to identify malicious URLs based on lexical features using machine learning approaches. Lexical features refer to those words, phrases, or patterns of characters that appear in a URL. Those features can provide important information about the content and purpose of a URL and can be used to distinguish between legitimate and malicious URLs. For example, a malicious URL may contain suspicious keywords that are not typically found in legitimate URLs. Machine learning is used for identifying malicious URLs based on lexical features because it can quickly analyze large amounts of data and learn complex patterns that are difficult for humans to identify. This approach is particularly useful for detecting new and emerging threats, where traditional signature-based detection methods may not be effective. By using machine learning to analyze lexical features, security professionals can quickly identify and block malicious URLs and prevent cyber attacks. So let's move on to the methodology. So this is the general flow of the project. The features are extracted from the dataset to train the machine learning models, and the performance of the model is calculated. So this is the data set, and I took the data set from the Kaggle. The content of the data set are as follows. So there are 4 types of URLs: benign URLs, defacement URLs, phishing URLs, and malware URLs. So what's benign URLs? Benign URLs are URLs that are considered safe and do not pose a threat to users. These URLs typically lead to legitimate websites. Defacement URLs. These URLs that are the URLs that lead to websites that have been defaced, meaning their appearance or content has been altered without authorization. Defacement attacks are a type of cyber attack where a hacker gains access to a website's backend and modifies its content or appearance to display their own message or image. Next is phishing URL. These URLs are such kind of URLs that are used in phishing attacks, which are a type of social engineering attack where a hacker or attacker tricks a user into providing sensitive information, such as password, credit card numbers, or personal information. Phishing URLs often lead to fake websites that look similar to legitimate ones, with the intention of tricking users into entering their sensitive information. And these are the examples that are contained in the dataset. Next is malware URLs. These URLs are used in cyber attacks to distribute malware, which is malicious software designed to cause harm to the user's device or steal their sensitive information. Malware URLs often lead to websites or downloads that contain malware, which can be disguised as legitimate software or content. Now, this is the general structure of a URL, and I am going to extract the feature from the URL itself. So these are the lexical features. I have used like 21 features for training the machine learning model. So these feature contains lexical features. Generally, cyber attackers use an IP address in place of domain name to hide the identity of the website. So this feature will check whether the URL has IP address or not. Similarly, counting the numbers of special characters in the URL, or checking the viability of the URL in the WHOIS database. So all of these features are extracted from the URLs present in the dataset. Now, the machine learning algorithm I used is support vector machine. It is a popular machine learning algorithm used for classification and regression tasks. SVM is popular supervised learning algorithm that works by finding the best possible decision boundary between different classes of data points in a high dimensional space. As you can see in the figure, the red points are separated from the blue points by a decision boundary. However, this is an example with only two features, x1 and x2. In my case, there are 21 features. And the next machine learning algorithm is random forest. It is a machine learning algorithm used for classification, regression, and other tasks. It is an ensemble learning method that works combining multiple decision trees to make predictions. It is resistant to overfitting and performs well on complex datasets. So this is an example of how a random forest structure is structured. The last machine learning algorithm I used is XGBoost, which stands for Extreme Gradient Boosting, and it is a popular machine learning algorithm used for supervised learning tasks such as classification and regression. XGBoost is an ensemble method that combines multiple weak prediction models such as decision trees to create a stronger or more accurate model. XGBoost works by iteratively training new models that correct the errors of the previous models. During each iteration, the algorithm evaluates the gradient of the loss function and with respect to the current model predictions, and uses this information to update the model's parameters. This process is called gradient boosting. Now moving on to the results. So this is the result of pre-processing, and the figure over here shows the word cloud. A word cloud is a visual representation of a collection of words where the size of each word represents its frequency or importance within the collection. So in this case, it's the data set that I used. So this is the word cloud for benign URLs. Now notice how the contents of the word cloud changes. Now all the previous word clouds seem to have words that may be common in legitimate URLs as well, like the defacement URLs, phishing URLs. But in case of malware, we see that there are different codes and numbers. So yeah, this is kind of a prominent that shows that the URLs are not normal. So I used 80% of the data set as training set and 20% of the data set as testing set. After I trained the model, I got these accuracies. So as you can see from this accuracy, the random forest algorithm performed well in comparison to others. And this is the source code. It's uploaded in the GitHub as well. And this is the paragraph that shows the feature importance of each machine learning algorithms. So feature importances indicate which features are most influential in predicting the output of the model. And in here also notice how the features have different importances. Like for the SVM, the highest is the abnormal URL feature, whereas in case of random forest, it's hostname length, and for the case of XGBoost, it's hostname length as well. So yeah, this was the result of my project, and now the conclusion. The random forest algorithm has proven to be effective in detecting malicious URLs in the current dataset. However, there is always room for improvement. By introducing network features or other features, we can get a better understanding of the URL's behavior and potentially improve the classification accuracy. Additionally, using a larger dataset can provide more data points for the model to learn from and may lead to improved performance. Embedding the model in applications for easy interface can also automate the detection process, making it more efficient and scalable for real-time monitoring. However, it is important to fine-tune the model's hyperparameters and carefully evaluate its performance on the new dataset to ensure that any new feature added or relevant and information for the classification task. So with this, I would like to conclude my presentation. Thank you and have a good day.